Hello, I'm Tana, your MLC tutor. Today I'm going to do a problem involving multiple lives, specifically last survivor probabilities. This is another one from my ASM study manual. It says that for 2 lives, future lifetime has probability density function f of st. So s and t are just the random variables that represent the future lifetime of our 2 statuses, s and t. That probability density function equals s plus t over 64. So it's a joint probability density function because we're looking at 2 different lifetimes. And they tell us that s has to be greater than 0 and t is less than or equal to 4. And they would like us to calculate the third quartile of the last survivor distribution. So the third quartile of the last survivor distribution. So that means that the probability that the future lifetime of our last survivor is less than or equal to some value, which represents the third quartile or the 75th percentile, equals 0.75. So the probability that the future lifetime of our last survivor status, S or T, I don't know which one it is less than or equal to some value. We don't know what it is yet, that's what we're trying to find. But it represents the 75th percentile or the third quartile. I'm going to call it A just because there aren't that many good random variables left that aren't already associated with something else that we know. We'll go with A. That equals 75% or 0.75. Okay, so the probability that a random variable is less than or equal to some value, that should automatically make you think of the cumulative density function. This is the cumulative density function for S and T evaluated at A and A, right? Because they both have to be less than or equal to A so that the probability is 75%. Okay, so the graph of this maybe, I don't know for sure, obviously, could look something like, it could look something like that. We're looking for some value, we're going to call it A, it's the 75th percentile or the third quartile, such that the probability that the future lifetime of the last survivor status is less than A is 75%. Okay, so 75%. So, what can we do with this? We want to solve for A. How can we do that? We need to know what the cumulative density function is. We have the probability density function, so we're going to integrate that. And if it's been a while since you took calculus, you might need a brief reminder on how this works, but it's really not too bad. The tricky part here, or at least for me, was the limits of integration. Of course, we're integrating with respect to, I'm going to do s and then t. It doesn't matter, you could do dt ds. Our limits of integration, both of our random variables are going to go from 0 to A. You can see that in the graph that we drew before. Initially, I thought you might have to do something like this, but no, we're looking for some A such that the probability that both of these random variables are less than A, right? So from 0 to A is 0.75. They both have to be less than that same value for the probability to be 75%. So once you have this set up, we know that this is 0.75. Honestly, that's the trickiest part of the problem. Now you just have to solve, now you just have to do the integration and solve for A. So if you're comfortable with that, you are good. You can probably do this on your own. I'm going to go through and finish it just in case somebody would like to see. Okay, so first I'm going to work on this inside integral. I'm going to pull the 1 over 64 all the way out to the outside. So we'll have, integrating with respect to s, so this s plus t is going to become 1/2 s squared plus ts. We're going from 0 to a, and on the outside we still have this integral from 0 to a with respect to t. Okay, so this becomes integral from 1 over 64 times the integral from 0 to a of 1/2 a squared plus ta with respect to t. Okay, so this is 1 over 64 times, we're integrating with respect to t, so 0.5 a squared t plus 0.5 t squared a evaluated from 0 to a, which is 0.5 a cubed plus 0.5 a cubed over 64. Like we said in the beginning, this whole integral was equal to 0.75. The probability that our last survivor status or the future lifetime of the last survivor is less than or equal to our third quartile, or 75th percentile, which is A, the probability that that's all less than A is 75%. So then you just need to solve for A, and I got 3.634. And that is our third quartile. So I hope that was helpful. Happy studying.